Okay, welcome to Covalent Bonding in Molecular Geometry. This is our first podcast. There will be 5 podcasts for this unit. This is the introduction to covalent bonding. Okay, let's get started. Alright, so let's go back and remind ourselves, what's the difference between an ionic and a covalent bond? So an ionic bond, if you recall, involves transferring of electrons, whereas a covalent bond involves sharing of electrons, sharing being the key word. Let's go back and take a look at what an ionic bond looks like. Alright, so here we have sodium and we have chlorine. And if you remember, sodium is in group 1, so it's got one valence electron. And it wants to lose that electron so that it has a full valence shell, just like we see inside here. Alright, we have chlorine, which has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. It wants to be like a noble gas also, to have a full valence shell, so it's going to add 1 electron. Okay, so what's going to happen is the sodium wants to lose its electron, so it's going to actually transfer that electron over to the chlorine. As a result, you can see now sodium only has these 2 shells, and it's got a full valence shell here. It's got 8 electrons, chlorine has its 8. And in the process, sodium becomes positively charged and chlorine becomes negatively charged. And that positive-negative charge creates a very strong attraction between the two. And if you recall, sodium chloride actually then exists as a crystal structure or crystal lattice where there's a whole bunch of Na pluses and a whole bunch of Cl minuses, all very strongly attracted to each other. Okay. A covalent bond is different. So here we have good old water. We have oxygen. It has 6 valence electrons, right? 1, 2, 3, 4, 5, 6. And then we've got 2 hydrogens. Each hydrogen comes in with 1 valence electron, so we'll make those X's so we can distinguish between the two. And what happens in the covalent bond is rather than transferring electrons, they get shared. And the goal in sharing is that each atom wants to end up with a full valence shell, be like a noble gas. So by sharing these hydrogens' electrons, the oxygen ends up with 8. 1, 2, 3, 4, 5, 6, 7, 8. And of course the hydrogens each end up with 2 because they're in the first period or the first shell, which can only hold 2 electrons, which makes it noble gas-like, right? Full valence shell. So everybody's happy, and it's in the process of sharing. Okay, so let's take a look now at what this actually looks like by looking at this animation. Here we have a hydrogen bond. We have 2 hydrogen atoms, and they are sharing electrons. So it's not like it exists as a stagnant pair in between them, but in fact, as you can see, the electrons are going around each atom and being shared in that way. Okay, so that's what a covalent bond would look like. Let's go back now. Okay, so if we take a look at a formula, we need to know how to distinguish whether or not we have an ionic formula or a covalent compound. Now, if you remember, an ionic compound is made up of a cation, and a cation, if you recall, is a positively charged atom or group of atoms. Remember, an ion is simply something with a charge. So most cations are metals, but there is one polyatomic ion, ammonium, that is a positive. And then it's also made up of an anion, and an anion is generally a nonmetal, but could also be a polyatomic ion. If you remember something like the carbonate ion, remember that list on the back of your periodic table? It could also be that. Okay, so let's take a look at some actual formulas. Okay, so before we do that, though, the covalent bond is different in that covalent bonds are made up of 2 nonmetals, 2 or more nonmetals. Okay, so let's remind ourselves how we look at the periodic table and determine whether we have a metal or a nonmetal. Remember this stair-step area right here? The grayed out section on your periodic table, those are metalloids, right? They have properties of both metals and nonmetals. And all of these yellows then, including these guys down here, are metals. Lots of metals. Remember, the periodic table is like 80% metals. And then these green ones are non-metals. Non-metals, right? So a covalent compound is made up of two non-metals. One of these, two of these, three of these. And the only non-metal over here, remember, is hydrogen. Hydrogen is a non-metal. It's not a metal. Well, sometimes it acts like one. Okay, so let's take a look at this formula here. Here we have carbon tetrahydride, also has a common name of methane. Let's take a look. So it starts with a carbon, and a carbon is a nonmetal, so this is going to be a covalent compound, also known as a molecular compound, right? A compound that has covalent bonds is a molecular compound. Here we have magnesium oxide. Now it starts with magnesium. Magnesium's right here. Magnesium is a metal, so this will be an ionic compound. Alright, sulfur dioxide. Sulfur is the first element. Sulfur's right here. That is a nonmetal, so this will be a covalent compound. Okay, here we have nitrogen trihydride, also known as ammonia. It's got a common name. And nitrogen's right there. It's a nonmetal, so this is also going to be a covalent compound. Alright, carbon dioxide starts with a carbon. Carbon is a nonmetal, so this is going to be covalent. Now, a lot of compounds that are covalent start with carbon. Remember, they're organic compounds. Very, very common. And here we have good old water, which we could give by its proper name, which would be dihydrogen monoxide. Hydrogen, as we said, is a nonmetal, so this will also be a covalent compound. Okay, so let's remember how